Today we are really getting deeper into canister development with Motoko, and then next week we will get into TypeScript and ASOP, and also some Motoko homeworks for you guys, for you to kind of play around and see how it's going. So let me share my screen. Okay, there's a Motoko playground. So I think for the case of like Afikile or anyone who might be having troubles setting up, because you get there, you get to set up. But there's this Motoko playground. I'm sure you are familiar with this thing of playground where you get to play with Motoko in this environment. But it's permanent. It's so temporary. Like you usually just use it for very temporary code you are just testing, or you have a small functionality which you want to share with someone, or which you're having errors with, and then you just want to quickly share with someone, and then like they can fix it for you right there, and then you can continue with your work. So this is what you would want to use. But it's so temporary that like if you just even refresh the page, the progress will be gone just like that. But it's actually really cool when you don't have cycles and you want like to test some mainnet functionalities. What it does is any canister that you deploy here on the playground, it gets deployed on the mainnet, but only for 20 minutes. And then after 20 minutes, that canister gets deleted. So you can write your code here and deploy. So yes, install the code to deploy. Yep. And you get the candid UI for your deployed canister, and then you can just say it. Say my name. Yeah. And it will give you back what you'll be expecting. So it's really a cool tool for some temporary code, testing code. And you can save and share, like what I was saying. You can save and share, and then you can just grab this link, and then you can share with someone, and they can see whatever you are cooking and help you if you're having some errors or anything. So yeah, really important too, but just know that your code is really temporary. If you forget it, you are trying to write some serious code, and for some reason you forget, you refresh your browser, it will be gone just like that. And the countdown, you can see it here, now on 18 minutes. Yeah, so a good tool to use, Motoko Playground. Sure, if you just search it, Motoko Playground, you'll find it. But I also send you guys. Yeah, I already sent you the link, by the way. So yeah. Anyway, let's get to our cool project we were working with yesterday, and move on to touch some concepts. So a recap for yesterday, we were talking about how you can import modules, external modules into your canister, modules from the base library or modules from you would have installed, like Motoko has its own package manager called mops. This is the package manager for Motoko. Yeah, you'll find some packages here. You can imagine Motoko is a new language. There's still very few packages. But yeah, for the case when you want to install some package, once you have it in your project, this is the type of way you would be importing it in your external modules, which can be types, functionalities. And today I will get to explain what I said yesterday, like the code you have in your modules shouldn't be really dependent on the state of the canister. So now we will get to see what is the state of the canister. As you might have already started wondering, like, so how exactly does the canister store storage up to like 400 gig of storage, right? So there are some in Motoko, for the case of Motoko, there are some stable variables which you will use as you are storing your data. In Rust, yeah, there are also some stable structures, stable byte map in TypeScript as well. Yeah. So here in Motoko, so let's say I want to create a counter, a simple counter app, right? I can have it as far, as we said yesterday, far will make the variable, yeah, mutable. Counter, you might give it a type or you might not. It's up to you, but it's a strongly typed language, Motoko. Here it will just kind of know what the value you have here. It's a nut. In some cases, it will scream at you. So let's create a function. Let's just call it function get sync, and it will return natural number. So it will just return the counter. So you can explicitly put the word return, or you can just return. It will work like that. So our function is not accepting any parameters, and then it's just returning the counter. So let's deploy this and test it out. Deploy. Okay, I have to start it. FX start playing background. You see, I always forget this. FX deploy. Now you see, like, this is one of the case I was explaining yesterday. Like, my canister, I just wanted to deploy the backend canister, but now I'm deploying the whole thing. So I should have just specified the name, the backend canister which I want to deploy. Okay, so here you can see it's empty. Why? Because this function, I didn't make it public. It should be a public function, right? Then let me deploy it again. Yeah. So, oh my God, fix deploy backend. Yeah. And then here it is. So if you notice something, it's taking a bit of time when I'm just getting this value, this get, and it's even nothing, but it's taking like a second or two. So this is another concept you just have to know as you are building your function. So if you remember from the videos we were watching on terminology, there are query calls and there are update calls, right? So if your function is going to change the state of the canister, it's an update call. And an update call, if you're familiar with the blockchains, an update call that is changing the state, it goes through consensus, where it goes through the function runs through multiple nodes so that they can agree each other on the validity of the message, right? Consensus. So an update function will go through consensus, so that's why it's slow. So by default, any function you create just like this, by default, it will be regarded as an update function. But now, if you know you're not going, this function is not going to alter any state of the code. It's just like returning values, just querying data. It should be a query function, and you do that by specifying the keyword query, and then then we'll know that this function isn't going to alter any state. And then it will execute much faster. So let's test this out. And what is happening here is this. So I have deployed my canister, right? There's a state that is already running in my deployed canister, and then I changed my canister. So it's now different from what was already deployed. So now it's asking me, there's an incompatibility that is happening, right? So it's asking me to confirm methods have been changed. Do you want to proceed? So this is important because sometimes it's not the function, sometimes it's the data structure here that would have changed in some way. And if you just do go about it blindly, it might mess up your data that we have stored. So that's what this check is about. It's just letting you know that the code you are deploying, you're installing, is different from the one that is already installed. There's some incompatibility. So do you want to continue? Then you just go yes. And then it will install. So now let's try to call this function again. So now you see it's executing instantly because it's now a query call. It's not going through consensus. So yeah, that's one thing to keep in mind. It will save you a lot of troubles. You might have a bunch of functions, and for some reason they are being slow simply because you forget the query keyword. So yeah, something to keep in mind. So let's now do public increase. Yeah. Shit. Pilot is cool. Not really. This is not the correct syntax. It's the function set counter to n, right? Yeah, and then let's run it. Let's see. So a new function won't ask you a lot of questions. Okay. Yeah. and it's working. So let's try to create another function for that is an actual update function. So let's say to just increase by 1, right? This is a long code. Close. Right. Let's, what is it saying? We need to assign this. Okay. Count plus 1. Okay. Now we need to return. Okay. Yeah. Then we increase a counter, query it. But now, when let's say I no longer want this function, I'm not sure what it's doing here. Then let me deploy my canister again. Yes. And then let me try to get, it's now 0. Why is it 0? Basically because the code was not persisted. It's starting on 0. So this is where the issue of stable storage and storing actual values in the canister comes in. So for these simple values, like just some natural numbers or arrays, you can make the variable, the state, permanent by using the keyword stable. Stable. Okay. Right. And now by this now, let me deploy again. So as you have imagined, I made some changes and I deployed. So let's see. Okay, I have to increase again by 2. Right. So for the changes to take effect, I need to make some code some modifications. What can I do? Let me just debug something. Yeah, and let me deploy again. Now let me get, yeah, now my state is persistent. So in simple ways like this, that's how you get your data to be persisted in the canister. So of course, this is a simple counter variable. This will be, yeah, hi Ben, go ahead.
So I have a quick question.
Yeah.
You went from a temporary variable to a stable variable, right?
Yes.
And then, but it kept the temporary variable available and then it transformed that directly into stable. So how does that work?
No.
Because it was in memory before, and then it remembered the 2, right?
No, when I put the stable variable,
yeah,
it didn't remember it. I mean, after I put the word stable variable, what I did is I increased and then I put this change. So the value that was stored before, it was the stable. No, it wasn't saved.
Okay.
It wasn't saved. Yeah.
I see.
Yeah. Okay, so yeah, that's it. Yeah, thanks for the question. Sure. So now let's try to create something that is actually um, real. Um, that is actually real. So let's continue with our user, right? We want to create some users. So yes, we have the created, updated ID. So for the case of users on the internet computer, especially if you're using like the internet identity, you don't really, in most cases, like you want the user to like log in with their internet identity and then like start using the application. Usually what you would want to store as the ID is the user's principal. So that way, with a user with pseudonym, who's like anonymous, right? And then they come to the application, they log in. Once they log in, they use their identity, their principal to access the canister. So I don't know if you noticed when I said like you have a command line identity, which I showed to you guys. Like I have a lot on this one. What is it? UFX identity list, right? And so I'm on my default identity. I would like to get my principal. So my principal is the unique identifier for my identity, right? So I can do dfx identity get principal. So this is a unique identifier for my default principal, and all these identities, if they are principals. And this is for my command line, all right? And then we also have the browser identity, the one you use with the internet identity. So let's just use the example of the NNS app, for example. This is the best one. Was this? So you see, I log in with my internet identity. Right. And if I, let's say what, open this, I want to see my principal. Okay, let me do receive. Now, where do I keep my principal? Okay. Mm, okay, yeah. Here is my principal. So yeah, I was just trying to show like for every identity, wherever you're having it, if it's associated unique identifier, which is the principal. So this value is normally when you have set up your internet identity, this is normally what you will be using. It's like a key identifier for users when they like log in into the application. You have this saved in the code. You have this saved here. So there's a unique type for this principal. It's actually called principal, like this. So in its actual form like this, it will be like an array bytes per se. There's not much detail here on its actual type. Okay, it's fine. But yeah, there's this unique, this actual principal type for a user principal. So you can use for a user who will be logging in with the internet identity, you can use this principal type, or you can use it as text for some cases, for whatever reason you would want. So you would be like converting the principal to text in this case. So the actual principal type, if a function associated with it for converting the principal to text. Let's see. Computer. Okay, I think we no longer have a lot of time. This will waste our time. But anyway, we will see all this. You can do some typecasting, converting it from a principal to a text, whichever way. So for this one, let's just use it as text. It will be easy to deal with as text. So anyway, and then you want to store the users, right? You would like a structure like what I was playing yesterday, like a hash map or a trie map, but you usually want to use a trie map. The hash map is also cool, but it has these small issues like it have an predictable insertion costs, like as your map is growing, for some reason it will what is it? It like rehashes the whole map, and then like that rehashing that will happen, like every computation that is happening, it have its cost, right? And then as you are just filling up your hash map with data, it have this unpredictable behavior where it can like rehash the whole table on its own, and then ending up doing some little bit more extra computational cost. So it's negligible, really, but like for a huge application, that cost can start to come to effect. So HashMap is cool, but you'll be better off using a trie map. So let's how you would declare a map for storing users. You would go with like variable. So we said if you want to modify, we'll go with variable. Let's say users trie map, right? So they are stored as key value pairs, right? In the trie. So the key, the identifier you will be using. So we have our ID that will be text, so we can do a text. No, it doesn't work like this. Let's try. This is accessing the module, this trie. And then if we do this trie map again, we are now accessing the actual trie map inside the module. And then here we specify the key. The key will be type text, and then the what I was explaining yesterday, user is equals to types dot user, and then the key will be what's happening here. Okay, the key will be user. And yeah, that will be it. And here is how you initialize it, and here you do text dot equal text dot hash some, right, and then that's how you initialize your try map. Right, and then adding a user now, you just do public add user. Is this correct? Yeah, normally we don't want to change anything, but it's fine. Yeah, that's adding the user. So this is basically how you go about CRUD applications, CRUD functionalities. Get user, this will be what? ID, right? Like this, right? Now, right here. ID. Yeah, so what's happening here, this question mark, the user might not exist in the map, the user with this specified ID. This can return a value or a no value users get, right? So that's why we do this, so that we can have the user or we may not have a user. So I think this is also an important place to introduce another important type that is called the result type. So as you can see, this is cool for a simple user, but like as the function starts to grow with some complex functionality, you just don't want to get a no when something like bad happens in the function. You want to know exactly what happened. So in that case, there is the result type that is available to us. So result dot result. So the first value of the result type will be, if everything went well, we would like to get a user. And then if something goes wrong, what we want, we just want a text. For now, for this case, we just want a text message that will tell us there's no user found. If it's something else, this will be an actual type of its own that you have created, that you have whatever some variance for the case. But in this simple case, if everything goes well, we want a user, and if there's an error, we'll get we'll do a text. So now, how do we go about it in the code now? So now we are handling two possibilities in our code. So we'll do a switch statement. Do a switch. So what's the value of like parameters we're saying user dot get? So if we get a user, we return an okay, wrapping the user, right? And then for the case of no, this is where we return error, user not found. So now our code is better. We can now understand exactly what's happening. Imagine you have some big variant and you have 5 cases. in all those cases, you want to know exactly what happens. So this is where the result types come to help, and the switch type helps you to handle those cases. Now let's deploy and test this out. Okay. Yeah, so add user candidate interface is cool. Like for every type you created, it will give you the interface so that you can test it out. We said our ID will be text. My ID. This is the date, that is just some number. Created it. So the updated value shouldn't be like expected right away. So you can make it optional by putting a question mark so that it can when it cannot exist. So let's update real quick. Let's go again. Okay. So my ID. Created it. Yeah, this won't know if the email is valid. So we add the user. Let's get the user by ID. User not found. ID. What's going on? This is the correct ID. But another problem which I noticed as well, function is a query function. It was a update function. I have to make it query. It was slow. And then let's see. User get ID. Oh, this is the error. This thing of just following Copilot. It was saving with the name. I want to save with the ID. That was the issue. Let me save again. Okay. Let me save again. Now let me query my ID. Okay, I have not refreshed. My ID should run quickly. There we go. Yep. So that's basically how you would go about basic user creation. You can imagine you start to have the other functions like delete user, get users, getting all users, and I think this might be a nice challenge as well for you guys to finish this after this call. Just try to put all the other functions to make this a complete CRUD. So we are adding, we are getting, and then you need to have delete, updates, and getting all user. So let me put this in Playground and then share with you guys, and then we'll call it a day. Motoko Playground. you know. But another thing you might have noticed, these users are not stable. I don't know if you can try to figure that out. But anyway, I'm just going to save and share with you guys. Cool. Any questions? We've come to the close of our session. No questions. Okay, that's fine. So yeah. Okay, one more thing, just to wrap up. Just to show you what I was showing you already. As you are playing around with this, trying to figure out if you're having challenges, trying to figure out how to implement the rest of the functions, just go to the Internet Computer website. While you are there, developer docs. Then you go to what? Motoko base library. Then you can see we're dealing with the trimap. Trimap is here. You can see how you can when you manipulate other stuff. Have the principal type people I was talking about. You can see to text, from text, is controller, a lot of other functions that are available for the principal, which are important. So yeah, that's it, guys. Thank you. Have fun with that. Try to complete the functionality. If you're having problems, just ping me on my Telegram. Yeah, good night. Let's catch up. Or tomorrow we are not having a session. We'll have it on Monday. We meet on Monday.
Well, thanks, Jess.
Come again?
Thank you.
Okay.
Cheers.
Okay, sure. Good night, guys.